Welcome to Trinath chemistry classes. In this video, I am going to discuss about first year organic chemistry, hydrocarbons. In this video, I am going to discuss about preparation of alkanes. In this video, I am going to discuss about preparation of alkanes. We know that hydrocarbons. What are hydrocarbons? Hydrocarbons are the compounds containing carbon and hydrogen are called hydrocarbons. What are hydrocarbons? Hydrocarbons are the compounds containing carbon and hydrogen are called hydrocarbons. And we know that hydrocarbons are classified into two types. One is open chain compounds. Second one is closed chain compounds. One is open chain compounds. Second one is closed chain compounds. And open chain compounds means they have long chains, carbon-carbon chains. Whereas closed chains means there is a closing of ring. These are called closed chain compounds. Again, these open chain compounds are classified into two types. One is saturated and another one is unsaturated. Another one is unsaturated. Right? Saturated means in this one, all the valencies of carbon are filled with only carbon-carbon single bond. If they are filled with carbon-carbon double bonds or carbon-carbon triple bonds, those are called unsaturated hydrocarbons. Hydrocarbons means compounds containing carbon and hydrogen are called hydrocarbons. Compounds containing carbon and hydrogen are called hydrocarbons. And these are classified into open chain compounds and closed chain compounds. Open chain compounds are again further classified into saturated and unsaturated. Saturated means in this we know that valency of carbon is 4 and the 4 valencies of carbon are filled only with other carbons with only sigma bond. Those are called saturated hydrocarbons. Examples for this, these are alkanes. In this video, I am going to discuss about how to prepare these alkanes. This is one of the important topic for intermediate public examination as well as all objective exams, all objective type exams such as NEET, JEE mains or FSET or MSET. For those exams, how preparation methods, how questions will be asked, I am going to discuss in this video. Right, we know that alkanes means these are saturated hydrocarbons. Alkanes means these are saturated hydrocarbons. Saturated hydrocarbons. Saturated hydrocarbons. These are having general formula CnH2n plus 2. CnH2n plus 2. The first member of this alkane series is methane. So this is the first member, and when n is equal to 2, C2H6, this is ethane, and similarly C3H8, this is propane, C4H10, butane, like this. These are the members of the alkanes. These are the members of the alkanes. Pentane, hexane, heptane, octane, like this. These are the members of this saturated hydrocarbons alkanes. So how to prepare these hydrocarbons? The first method for the preparation of hydrocarbons is decarboxylation. What is the first method? This is decarboxylation. What is decarboxylation? Decarboxylation means when sodium or potassium salts off. Sodium or potassium salts off. Potassium salts off. Carboxylic acids. Carboxylic acids are treated with soda lime. Treated with soda lime. Treated with soda lime. We get alkanes. Soda lime, we get alkanes. This reaction, we are calling it as the decarboxylation. This reaction, we are calling it as the soda lime. With this reaction, alkanes are formed. This reaction, we are calling it as the decarboxylation. This reaction, we are calling it as the decarboxylation. This reaction is called decarboxylation. Decarboxylation. Here, soda lime means it is a mixture of NaOH and CaO. It is a mixture of NaOH and CaO. That mixture, we are calling it as the soda lime. That mixture, we are calling it as the soda lime. Here, when we know that carboxylic acids means compound having RCOOH group are called carboxylic acids. When carboxylic acids are treated with sodium or sodium hydroxide, we get the sodium salts of carboxylic acids. We get the sodium salts of carboxylic acids. When carboxylic acids are treated with sodium or sodium hydroxide, we get the sodium salts of carboxylic acids. When these sodium salts of carboxylic acids are treated with soda lime, that is a mixture of NaOH and CaO, we are getting alkanes. We are getting alkanes. This reaction, we are calling it as the decarboxylation. We are calling it as the decarboxylation. What is decarboxylation reaction? The decarboxylation reaction means when sodium or potassium salts of carboxylic acids are treated with sodium or potassium salts of carboxylic acids are treated with soda lime, alkanes are formed. This reaction, we are calling it as the decarboxylation. We are calling it as the decarboxylation. Right? So here in this decarboxylation reaction, what is this this decarboxylation reaction involves this decarboxylation reaction involves the formation of CH bond. Formation of CH bond. Formation of CH bond. For example, here we know that this R group is called alkyl group. This R group is called alkyl group. Here, for example, if you take sodium salt of ethanoic acid is treated with soda lime. Sodium salt of ethanoic acid is treated with soda lime. Here, what is the alkyl group? Here we are getting methane. Here, whatever the alkyl group is there, to that alkyl group we are adding one hydrogen. This reaction, we are calling it as the decarboxylation. For example, if you take C2H5, C double bond ONA. If you take sodium propanoate, when sodium salt of propanoic acid is treated with soda lime, we will get C2H6. Here, what is the alkyl group? C2H5. I am adding a hydrogen. That's why we are getting C2H6. For example, if you take C3H7, C double bond ONA, sodium salt of butanoate, if you get C3H8, propane we will get. Suppose if I want to prepare C4H10, then what I have to take? C4H9COON. So in objective point of view, question may be asked like this. When sodium salt of ethanoic acid is treated with soda lime, what you will get? We will get methane. Suppose to get ethane, which reactant has to be taken to react with soda lime? Then we have to treat with sodium salt of propanoic acid. So this is the first method, that is decarboxylation. So decarboxylation means in this alkanes are prepared by treating sodium or potassium salt of carboxylic acids with soda lime. This is the first method. Then second method is coal-based electrolysis. In coal-based electrolysis, when sodium or potassium salt of sodium or potassium salt of carboxylic acid is electrolyzed. Carboxylic acid is electrolyzed. Alkanes are formed at the alkanes are formed at the anode. Alkanes are formed at the anode. This reaction we are calling it as the coal-based electrolysis. When sodium or potassium salt of carboxylic acid is electrolyzed, means what is electrolysis? Electrolysis means in this a compound is electrolyzed. A compound is decomposed by passing electricity through its aqueous solution or in molten state. Aqueous solution or molten state. That phenomena we are calling it as the electrolysis. Here, when sodium salts of carboxylic acids are electrolyzed, on electrolysis, on passing electricity, we will get alkanes at anode and hydrogen is liberated at the cathode. Hydrogen is liberated at the cathode. Here, this reaction involves the CC bond formation. CC bond formation. In previous method, that is in decarboxylation, involves the formation of CH bond. But this reaction involves the formation of which bond? CC bond. This reaction involves the formation of CC bond. This is the second method, coal-based electrolysis. For example, if you take CH3COON on electrolysis, we will get CH. Right here, whatever alkyl group is there, there's two alkyl groups, the CH3CH. And this method is not suitable for the preparation of methane. Coal-based electrolysis is not suitable for the preparation of methane. Methane cannot be prepared by this method. The reason is methane contains only one carbon, but this reaction involves the formation of CC bond. That's why methane cannot be prepared by this coal-based electrolysis. Here, in objective point of view, we need to remember alkanes are formed at the anode and hydrogen is formed at the cathode. Hydrogen is formed at the cathode. This is the second method, coal-based electrolysis. Then third method is Wurtz reaction from alkyl halides. Third method is Wurtz reaction. What is Wurtz reaction? Wurtz reaction means when alkyl halides are treated with sodium in the presence of dry ether. In the presence of dry ether. In the presence of dry ether, alkanes are formed. Alkanes are formed. This reaction, we are calling it as the alkanes are formed. This reaction, we are calling it as the Wurtz reaction. We know that alkyl halides means, alkanes means having general form. Alkyl halides means, alkanes means what is the general formula? CN H2n plus 2. When hydrogen is removed, then that group we are calling it as the alkyl group. In this, hydrogen is replaced with halogen. We are getting alkyl halides. We are getting alkyl halides. When alkyl halides are treated with sodium, alkyl halides are treated with sodium in the presence of dry ether, alkanes are formed. This reaction, we are calling it as the Wurtz reaction. We are calling it as the Wurtz reaction. When alkyl halides are treated with sodium in the presence of dry ether, alkanes are formed. This reaction we are calling it as the Wurtz reaction. For example, CH3CX, CH3Cl, when treated with sodium in the presence of dry ether, alkanes are formed. C2H6 plus 2 and S. This reaction we are calling it as the Wurtz reaction. We are calling it as the Wurtz reaction. You see, in this Wurtz reaction also involves the formation of CC bond. These points are important for objective point of view. This alkanes Wurtz reaction involves the CC bond formation, and this method is suitable only for the suitable only for the alkanes containing even number of carbons. Alkanes containing even number of carbons. Even number of carbons, which means the alkanes containing even number of carbons 2, 4, 6. For those only this method is suitable. You see, and methane cannot be prepared by this method. Methane cannot be prepared by this method. What is Wood reaction? When alkyl halides are treated with sodium or potassium in the presence of sodium in the presence of dry ether, alkanes are formed. This reaction we are calling it as the Wood reaction. This reaction we are calling it as the Wood reaction. When alkyl halides are treated with sodium in the presence of dry ether, alkanes are formed. And the important points in this Wood reaction, objective point of view, is this reaction involves this EC bond formation, and it is suitable only for the preparation of alkanes containing even number of carbon atoms, and methane cannot be prepared by this method. You see here, what is the meaning of it is not suitable for the preparation of compounds containing even number or odd number of carbons. The reason is, you see, for example, if you want to prepare C3H8 propane, then we need to take CH3Cl plus C2H5Cl. You see here, when we take CH3Cl plus C2H5Cl along with sodium, what we will get is, along with C3H, we may get C2H6 and C4H. You see, 1 mole of this, 1 mole of methyl chloride and 1 mole of ethyl chloride, both are reacts, we will get propane. But when 2 moles may react, 2 moles of this may react and forms butane. You see, along with the required product, we may get other products, side products. So that yields of required product will be reduced. That's why this method is not suitable for the preparation of hydrocarbons, alkanes having odd number of carbons. So this is the third method. You see, maybe we have discussed so far 3 methods: decarboxylation, and the second one is coal-based electrolysis. Third one is Wood reaction. You see, for example, the in objective point of view, question may be asked like this: which of the following method is not suitable for the preparation of methane? Decarboxylation, coal-based electrolysis, Wood reaction. All. What is the option? B and C are not suitable for the preparation of methane. Right? Then next method is Franklin reaction. So Franklin reaction is same as that of Wood reaction, but here when alkyl halides are treated with zinc, alkanes are formed. In the presence of sodium, in place of sodium, we are using which metal? Zinc we are using. This reaction we are calling it as the Franklin reaction. So this, in this method also, what is the disadvantages? Whatever in Wood reaction we have said, no, all those disadvantages will be there. Here, this reaction involves the CC bond formation. Methane cannot be prepared by this method. And third one is, this reaction also suitable only for the preparation of alkanes, having even number of carbons. This method is not suitable for the preparation of alkanes having odd number of carbon atoms. Right? This is the fourth method. Then next one is from Grignard reagent. What is Grignard reagent? Grignard reagent means alkyl magnesium halide is called Grignard reagent. Alkyl magnesium halide. It is generally treated with RMGX. Alkyl magnesium halide is called Grignard reagent. Grignard reagent is prepared by, when alkyl halides are treated with magnesium, we will get Grignard reagent. Grignard reagent. What is Grignard reagent? Alkyl magnesium halides are called Grignard reagents. Alkyl Grignard reagent is prepared by when alkyl halides are treated with magnesium, alkyl magnesium halides are formed. Right? When this Grignard reagent is treated with compounds containing acidic hydrogen, such as water, ethanol, like this, if you take a phenol, like this, these compounds, if you treated, no, then RH will be formed. Right? RH. Here, this reaction involves the formation of CH bond. And for example, if you take CH3MgCl, when treated with water, is a water containing acidic hydrogen. That's why we will get like this. Here, methane can be prepared by this method. Methane can be prepared by this method. So far, we have discussed 5 methods. Among these methods, only in decarboxylation and from Grignard reagents only we can prepare the methane. Here, decarboxylation and from Grignard reagent, both the reaction involve the formation of CH bond, but the remaining 3 reactions, coal-base electrolysis, Woodge reaction, and Franklin reaction involves the formation of CC bond. CC bond. So this is regarding from Grignard reagents. From Grignard reagents. Then next one is from unsaturated hydrocarbons. Next one is from unsaturated hydrocarbons. Unsaturated hydrocarbons. We know that unsaturated means the compounds having carbon-carbon double bond or carbon-carbon triple bond. We know that carbon-carbon double bond containing are alkenes, triple bond are called alkynes. When alkenes are treated with H2, treated with hydrogenation in the presence of nickel, platinum or palladium at 200 degrees centigrade, we will get alkenes. We'll get alkenes. Similarly, when alkynes are treated with hydrogen in the presence of nickel, palladium or platinum, 2 moles of hydrogens will be added and the alkenes are formed. Here, electrophilic addition takes place. What is the reaction occurring here? Electrophilic addition reaction. Electrophilic addition reaction. Here, what is the reaction occurring? Electrophilic addition reaction. Right? Here, in this method also involves this method also involves the CH bond formation, and methane cannot be prepared by this method. Methane cannot be prepared by this method. Right? Here, when unsaturated hydrocarbons, either alkenes or alkynes, treated with nickel or hydrogen in the presence of nickel, palladium or platinum, alkenes are formed. Here, this reaction involves the CC bond formation. Here, when these alkenes or alkynes on reaction with the hydrogen in the presence of nickel at 200 degrees centigrade, alkanes are formed. This reaction, we are calling it as the Sabatier-Senderens reaction. Sabatier-Senderens reaction. Sabatier-Senderens reaction. Sabatier-Senderens reaction. This reaction we are calling it as the Sabatier-Senderens reaction. Right? Here, this is the one more named reaction in the preparation methods of the alkanes. Then next one is from carbonyl compounds, that is from aldehydes and ketones. From carbonyl compounds. Carbonyl compounds. We know that carbonyl compounds means aldehydes and ketones are called carbonyl compounds. This is called aldehyde group, this is called ketone. In this first one is, there are 2 methods in this one. First one is Clemenson's reduction. Clemenson's reduction. When aldehydes or ketones treated with zinc amalgam by HCl, alkanes are formed. Aldehydes or ketones on reduced reduction with zinc amalgam by HCl, alkanes are formed. This reaction we are calling it as the Clemenson's reduction. Clemenson's reduction. Aldehydes or ketones on reduction with the zinc amalgam by HCl, alkanes are formed. This reaction we are calling it as the Clemenson's reduction. You see here, to prepare methane, what is the reactant we need to take? Formaldehyde. Formaldehyde. Zinc amalgam by HCl. Second one is Wolff-Kishner reduction. Second one is Wolff-Kishner reduction. What is Wolff-Kishner reduction? Wolff-Kishner reduction. In Wolff-Kishner reduction, aldehydes or ketones treated with hydrazine in the presence of base, alkanes are formed. Alkanes are formed. This reaction we are calling it as the Wolff-Kishner reduction. Wolff-Kishner reduction. Now, what is Wolff-Kishner reduction? When aldehydes or ketones treated with hydrazine, this one we are calling it as the N2H4. This is called hydrazine. In the presence of base, alkanes are formed. This reaction we are calling it as the Wolff-Kishner reduction. You see, what is the difference between Wolff-Kishner and Clemenson's reduction is? In the Clemenson's reduction is an acidic medium, occurring in acidic medium, but this is occurring in basic medium. In these, both these methods are suitable for the preparation of methane. Both the methods are suitable for the preparation of methane. And this is the reaction example for the reduction reaction. It involves the removal of oxygen and addition of hydrogen. So this is the another method for the preparation of alkanes from carbonyl compounds. You see here we have discussed Wurtz reaction. What is Wurtz reaction? When alkyl halides are treated with sodium, in this alkanes are formed. And this reaction is not suitable for the preparation of alkanes having given number of carbons. To prepare odd number of carbons, to prepare hydrocarbons having odd number of carbons, the method used is Core-House synthesis. Core-House synthesis. You see, in Core-House synthesis, when alkyl halides are treated with lithium, we will get alkyl lithium, and this alkyl lithium on treatment with cupric iodide, we will get R2CuLi. Dialkyl lithium cuprate. Dialkyl lithium cuprate. Cuprate. This reagent is called Gelman's reagent. Gelman's reagent. When this Gelman's reagent is treated with, when Gelman's reagent is treated with alkyl halide, we will get alkanes. We'll get alkanes. This reaction we are calling it as the Core-House synthesis. When, for example, CH3 twice CuLi, when treated with C2H5Br, we will get C3H8. This is the one and only product formed. You see, in Wurtz reaction or Franklin reaction are not suitable for the preparation of hydroalkanes having odd number of carbons. To prepare alkanes having odd number of carbon atoms, the most suitable method is Core-House synthesis. In this Core-House synthesis, what are the reactants? Gelman reagent is reacting with alkyl halide. Gelman reagent is reacting with alkyl halide. How this Gelman reagent is prepared? Alkyl halides are treated with lithium. We will get lithium, alkyl lithium. When this alkyl lithium is treated with cupric iodide, we are getting dialkyl lithium cuprate. Lithium cuprate. This one we are calling it as the Gelman's reagent. So these are the methods to prepare for alkanes, for the preparation of alkanes. So what are the methods we have discussed? One is decarboxylation, decarboxylation. Second one is pool base electrolysis. Pool base electrolysis. Third one is Woods reaction. Fourth one is Franklin reaction. Fifth one is from Grignard reagent. Grignard reagent. Then sixth one is from unsaturated hydrocarbons. Here we have seen Sabatier entrance reaction. Then Clemenson's reduction. Then Wolff-Kishner reduction. Wolff-Kishner reduction. Then last one is Core-House synthesis. Core-House synthesis. And in IPE point of view, first these three methods are most important. IPE point of view, right? So here, in objective point of view, question may be asked. They will give reactants. They may ask you to write the product, or they will give the reactant and product. They may ask you to write the reagent. For example, if like this is asked, aldehyde to alkane, what is the Clemenson's reduction and Wolff-Kishner reduction? Right? So these are the preparation methods for the preparation of alkanes. Thank you. Thank you for watching Trinath chemistry classes. Please subscribe my channel, share and like the video. Thank you.